Just wait for the bar to go across and we'll be right. Okay, Nigel, you can start now. Thanks.
Thank you, Nikki. Sorry, can I just check that you're seeing a slide?
A lovely muddy estuary.
Lovely. Okay, smashing. Thank you very much, Nikki. And good evening, everyone. As you know, my name is Nigel Mortimer. I'm the Estuaries Officer with South Devon AONB. I'm going to be talking to you about something that's very dear to my heart, obviously professionally, but I'm going to be starting to go into a little bit of depth about what estuaries actually are, why they're special and why we should really be caring for them, and then go on to a little bit about what we can all do to help look after them, conserve them, and indeed enhance them. So I work for the AONB Estuaries Partnership, and here are our funding partners. Thank you very much to them. So obviously the South Devon AONB is very much centred around our 5 wonderful estuaries: the Yelm, Avon, Salcombe Kingsbridge and Dart. As Nikki suggested, the AONB is a designated landscape, and as I just said, very much centred around our estuaries. Nearly all of them are within the AONB. There's a tiny little bit at the top of the Dart that isn't. And with the Avon estuary, it goes right the way up some of the river as well. So, of course, the AONB is covered by its own management plan and managed by the small AONB unit. And the estuaries and rivers are very much at the heart of the AONB management plan. And we actually have our own estuaries management plan itself. And you can pick those all up, download them from the AONB website. So our local estuaries range from some of busy harbours, beautiful, tranquil areas, areas that are really quite built up, open mud flats, the whole range there. But first of all, let's start with what an estuary actually is. Now, obviously, an estuary is where the salt water of the sea mixes with the fresh water of normally a river. And because of the slope of our estuaries and the rise and the fall of the tide, that means, of course, that where those two waters mix actually moves up and down the estuary with the tides. In some places, there is actually an upper limit where the fresh waters will cascade down over. But in many areas, it just very much depends on where the tidal waters actually reach. So an estuary, if you like, is that zone of mixing of fresh and salt waters. And this, of course, has a huge bearing on the ecology of our local estuaries. At high water, of course, we've got the extensive areas of water, and many of our estuaries enjoy huge areas of mudflats at low water. Now, of course, that means that that habitat is actually an incredibly difficult place to live. With the tide in, of course, you've got the whole water column as a habitat for many fish, many animals to thrive in. But as the tide recedes, of course, the shores are exposed. And of course, then they're exposed to whatever the weather is going to throw at them. The depth of the winter, things might freeze. The height of the summer, things will bake. If it's a very windy day, things will dry out. So you're getting those absolute extremes twice a day. And then on top of that as well, of course, you've got the salt water of the sea. And in places like rock pools, maybe some of the water might even evaporate. It would become even more salty. And then, of course, you've got the fresh water coming down from the streams and the rivers. And of course, being in the southwest, We get colossal amounts of freshwater rain sometimes. So even the likes of the Salk and Kingsbridge estuary, which we normally think of as more of a marine inlet, can be really well diluted by all that fresh water. So all those extremes, and they're forever changing throughout the day, actually make estuaries an incredibly difficult places for wildlife to thrive. Now, when we talk about places worthy of conservation, we normally go for the areas that have what we describe as having very high biodiversity. Now, estuaries are really rather odd. Estuaries, because they are such difficult places for wildlife to exist, the biodiversity is actually incredibly low. If you look at the graph here, this is a percentage index of the diversity within here, the freshwater environment. And at the other extreme, the salinity along the bottom here, at the other extreme, full seawater, marine conditions, you get a very high biodiversity. But in the middle, the biodiversity drops off, and it's because it is such a difficult place to live. And the vast majority of animals and plants that we find within our estuaries proper are actually marine animals and plants that are capable of living within this changing freshwater, saltwater conditions. There are very few freshwater animals and plants that will are able to live if they get washed down into the estuary. The typical examples of things that can are things like salmon and trout, but the vast majority of insects that thrive in the rivers and streams, if they get washed down, they become estuarine fish food. But even though we have this area where the biodiversity is low and hugely dominated by a few species, their productivity, the biomass that estuaries support is incredibly large. This is a graph here taken out of context, really, but just if you compare rivers, estuaries and seas, the production, the productivity that you get within estuaries is incredibly high. So, we mustn't always go for places with high biodiversity, but sometimes places like estuaries, it's the amount, that's the biomass, the population of the individuals that are actually all important. Now let's have a look about what that salinity and the muddiness of the estuaries actually mean to the wildlife. Now in this test tube, what we've actually done is floated dyed fresh water over salt water. I'll be honest with you, we made sure that it was a bit more salt there just to make sure that the densities were right. But that is what is happening in calm conditions of estuaries. So when the salt water of the sea comes in with the tide, the salt water actually creeps along the bottom of the estuary. And when particularly in calm conditions, when the fresh water of the river flows out, it floats out over the top of the estuary. This means that you get a lot of migration of animals within estuaries with the tides. Things like crabs can hunker down into the mud on the bottom where the salt tends to linger, and they'll migrate down into the mud with each tide. Things like birds can obviously fly up and down the estuary with the tides, and fish too will often migrate. And a lot of the marine fish will actually come in along the bottom of the estuary for that very reason, that the salt water comes in at the bottom as a wedge. And partly helped by their shape, the very first fish normally to come in are the flatfish. And very often, as the tide comes in, you'll see fish-eating birds will follow the tide up as well, and they are diving down looking for those fish. Now, the other big thing about estuaries, of course, is that they tend to be very muddy, dirty, smelly places because of all that mud. And in this part of the Salk and Kingsbridge estuary, the mud there is something like 7 meters deep. In other estuaries, it can be at least twice that. Now, estuaries are muddy for a couple of reasons. If you think back to your sort of O-level geography days, you'll remember that the energy of streams and rivers will have a carrying capacity. They'll bring in the flowing water bits of sand, bits of silt, any organic bits, and that will carry those while the water has energy. And then when the rivers come out into the wide areas of the estuary, that loses that energy, and that the heavier particles will, of course, settle out fairly quickly. But also, with the fresh water meets the salt water, the salt water actually has the effect of clumping the particles together, making them bigger and heavier so that they settle out too. So that's why estuaries get this double whammy, if you like, of silt. But of course, it's not just particles of sand and silt, but it's also an awful lot of organic matter that's brought down from the water catchment, or indeed coming in from the sea. And by the way, that process is called flocculation, and there are other people that will be far better to try and explain the processes to you of that. But that is the reason that estuaries are such muddy places. Now, I mentioned that a lot of the matter that settles into estuaries is this organic matter. So you have bits and pieces of dead and dying freshwater species brought down, the leaves and bits of plants that flow down from the water catchment. And then from the sea, again, bits and pieces of dead animals washed in, the plankton itself, and of course, the masses of seaweeds that get washed in as well. All that snows down onto the bottom of the estuary, a huge amount of organic material. Now, with such a colossal amount of organic material there, bacteria are there eating that up, if you like, breaking that organic material down. And anywhere you have large numbers of bacteria, you'll also have high numbers of viruses. Now, on the whole, those bacteria are relatively harmless to us, but there are so many of them. In fact, we normally suggest that within just 3 teaspoons of mud, there are as many bacteria as there are people on the planet. But with the growing population of the planet, we have now moved to teacups of mud. There are so many bacteria in the surface of the mud that just 1 centimetre down, the bacteria living there have used up all the oxygen. And the bacteria that live below that don't use oxygen like we do. They are using other more exotic chemicals to live down there, and that makes the mud quite black and quite anoxic. Anoxic means just without oxygen. So dig any distance down at all into estuarine mud, and it's black. And it's not oily, it's black because of these anoxic conditions. And very often those muds are very smelly because some of the chemicals that are liberated by the bacteria are there released, and things like hydrogen sulfide, which of course gives you the nasty smell of rotten eggs. So those bacteria there in colossal numbers, if you just, even if it's 4 teaspoons of mud, multiply that up over the extent of mud that we have across our estuaries, and it's huge numbers. Those bacteria then release the nutrients that they've broken down from the organic material, and then those nutrients are available for plants to grow. In estuarine conditions, these are diatoms on the surface of the mud. Now, I know it doesn't terribly come out well on the slide here, but in natural conditions, it's a lovely golden brown color. And if you go down to a glistening mudflat in the height of the summer, that golden brown sheen that you have over the surface of the mud are these diatoms. These are single-celled seaweeds, if you like. And what's really interesting about these is that they can actually move their real life tiny, tiny little triffids, if you like. Now, they don't move huge distances, but they're just able to migrate up and down through the very surface of the mud with the tides and day and night. And what they do is at low tide, during daylight hours, these millions of diatoms comes to the surface and photosynthesize using the energy of the sun and the nutrients from around them. Of course, with that sheen of diatoms over the surface, that is food for something else. And you have things like these tiny little hydrobia snails, apparently up to about 10,000 of these per square meter, and each one the size of a pinhead. And of course, they are then food for other things, something like shell duck. And if you watch these ducks waddle across the surface of the mud, you'll see them scything backwards and forwards with their bills, sifting out things like these hydrobia snails. Of course, there's other things in the mud. There are shrimps, clams, crabs, all sorts of things down there. And at the microscopic level, the mudflats of estuaries are actually really quite diverse. It's the larger organisms where the biodiversity goes right down. Now, in the slide here, this is the end of a pipe of the siphon of an animal called a telin, and they are a tiny little clam that live, 6 or so inches below the surface of the mud. They have 2 tubes. One of them comes right up to the surface, and at low tide, they can use these like little vacuum cleaners, sucking up the detritus and the diatoms and things from the surface of the mud. And the siphons are so thin, you can actually see food go down the siphon. When the tide is properly in, the siphon goes up into the water, and they are filtering out plankton and other organic matter from the seawater above. The second siphon is for them to excrete from when they've digested, and they filter whatever food they're going to feed on through the gills of the animal inside the shell. Now, apparently, one of the things that when the flatfish are coming in with the tides, they like to eat the ends of these tubes. So these poor little telins are very often having to regrow their tips. Nikki and I have actually lain down on an incoming tide on the edge of a pontoon, and you can actually see some of this life sort of almost getting excited for the tide to come in. It sounds like an odd thing to do, but it's well worth doing. Just as the tide is reaching a pontoon, just watch some of the life come to life in the mud right in front of you. You can actually see some of these siphons, ragworms and things coming out and starting to feed. But of course, with so many different organisms there, many people think of estuaries as feeding supermarkets for birds. And to some extent, indeed, they are. And if you look at all the different estuarine birds, they all have different lengths of bill for feeding on different organisms from down in the mud and the like. But as a marine biologist, I tend to get more excited about the fish that estuaries support. They are generally more numerous and more, I would argue, more colourful than the birds. It's the trouble is we just don't see them because they're very much hidden by the water. Now, of course, as we all know, every estuary is is unique, and that comes down to its form, the size of the catchment, the amount of fresh water coming in, the heights of the tide, the state of the tide, how turbid the water is, the variety of natural habitats, and of course the richness and abundance of the wildlife there too. Now, in the UK, we have 9 different kinds of estuary, but nearly all the estuaries in the southwest are what we call these RIA, or drowned river valley type estuaries. And I'll explain a bit more about them in just a second. But the ex-estuary, I believe, is a bar-built estuary. But like I said, nearly all the estuaries in the southwest are RIAs. There's a lot of confusion about, yes, we know the Salk and Kingsbridge is a RIA, but actually so is the Avon, so is the Erm, so is the Yelm. So a RIA, or a drowned river valley, they have formed through the carving and the energy of a river flowing down from the catchment, carving its way down through the soil, the sediment and the rock to create this sort of long, deep and steep-sided river valley. But after the last ice age, when the sea levels had risen by about 120 meters from where they were during the ice age, they then flooded many of these river valleys that had formed maybe before or during the ice age, with the colossal amounts of fresh water that were flowing down. So we have 5 estuaries in South Devon, all very different, but 2 of these are real extremes. Now, if you consider the Dart estuary to begin with, the Dart estuary is a very freshwater dominated estuary. What we mean by that is got a very large rain water catchment area. So if you get a massive rainfall event in Dartmouth, you get this surge of fresh water coming all the way down. And you can have fresh water flowing out over the top of the estuary all the way down at Dartmouth, apparently. If we then take the other extreme, the Salcombe-Kingsbridge estuary, that's a very marine-dominated estuary. And look at the very tiny catchment. It doesn't go anywhere near Dartmoor. So the catchment of fresh water is that much less. So the penetration, the amount of marine water that comes in.
Sorry, Nigel.
Hear me again? Great. Okay. So the Salcombe-Kingsbridge estuary is much more marine dominated. And that does mean that the biodiversity of life within the estuary is that much higher because it has more naturally marine type conditions. And it also means that right at the heart of the estuary, we have some very, very sheltered but fully marine habitats. And there are 1 or 2 habitats within the estuary which are meant to be almost unique within the UK. So you can see, quite naturally, very, very different estuaries right next door to each other. So what? What does that mean to us? Well, let's go through what estuaries do for us. What are their ecosystem services that we enjoy? Of course, they have a lot of plankton, a lot of plants within the seaweed. So they use up our waste product, our carbon dioxide, and they throw away oxygen, which is kind of nice for us because that's what we breathe. They are nursery grounds for a lot of fish. So many of the fish that we eat either start their lives as eggs or come in as a young fish into estuaries, or indeed they may spend some of their life there too. Estuaries, if you like, are the natural wastewater treatment works for the water catchment areas. And of course, for us down in the southwest, they are fantastic with their deep water ports. They are our water playgrounds, if you like. And right now, for many of us, or no, I'm jumping ahead of myself. Sorry. And the other thing is that, is very much in the news at the moment is how important some of the habitats and communities within estuaries are so incredibly important for the amount of carbon they take up and lock away. So we've got the salt marsh, which is the king of them all for the amount of carbon that they take up and lock away within our estuaries. We've got the tidal reed beds. These can look a little bit kind of sort of a bit boring, if you like, because it's just one species, but they are incredibly important. Our saltgrass meadows, but also too, indeed, the mudflats. If we compare the amount of carbon that these different communities lock away. Okay, we don't have mangroves in this country, but our tidal salt marsh and our seagrass meadows are way higher than places like jungles and, tropical rainforests. They really are incredibly important. And because, let me go back a second. Because of the amount of mud in the bottom of the estuaries, we have got huge amounts of carbon locked up there for a very, very long time. So, it's very much in our interest to look after our estuaries to stop that release of the release of carbon back into the atmosphere. And on a webinar today that reckons that today we only have 1/10 of the seagrass that we used to have. And with some of our mudflats, without the cover of seagrass over them, they may actually be losing more carbon than they are storing away. So, in the future, we certainly want to be trying and conserving and enhancing some of these habitats above. And right now, during the COVID pandemic, they're also incredibly important for our well-being. Places like this, just to spend a few minutes, hours, whatever, just to recharge our own batteries. It certainly sort of raises my hopes, that's for sure. So what are the challenges of all of these? Well, to a huge extent, one of the big problems is that we don't see what's going on. We don't see the underwater topography of our estuaries and just how varied they are. We tend to stand on the edge of a cliff and we look back over the AONB and we can see the varied topography behind us. We look out to sea, and it's very easy to believe it's almost easy to believe that because the water's flat, the seabed must be flat as well. But actually, it's just as varied as the land behind. And so are parts of our estuaries too. We don't see some of the beauties within our estuaries. I had to confess, this sun coral you don't find within estuaries, but it's a beauty, and I just had to use that slide. We don't see some of the ecosystem services that our estuaries supply for us. We don't see a lot of what's going on because of the microscopic scale of some of the things that are going on here. And it's worth pointing out, by the way, at this point, that not all plankton is tiny. Jellyfish are actually part of the plankton. So we tend to think of plankton as having to be tiny. It isn't. A lot of it is, but it doesn't have to be tiny at all. And sometimes you just can't see what's going on. You can't see the wood for the trees, if you like, or in this instance, you can't see the leaves for the grasses. So, we know that seagrass meadows, as an example, are incredibly diverse with the amount of life that they support within them. But if you put your head in them, you can't see anything but the leaves of the grass there. And that's why they're such good places. A lot of fish that we like to eat, they use the seagrass beds as nursery grounds because the fish can go in there and hide from predators. And the other big thing, of course, is that hidden under the water, we don't see a lot of the problems that are happening down there. We don't see the great masses of plastic and other debris that are building up at the bottom of the sea. Now, I'm sorry if this is your own back garden, but we're kind of lucky in the southwest that we don't have any of this kind of heavy industry. If you like, our heavy industry is farming. It's the working of the land. But, okay, I showed a smoky old chimney there, but our local farmers have very much the conservation of the soil and the land around them. They have that at their heart, so they are investing in that. And, they're very open to science and following the best example. But at the moment, they're, with the climate change and the changing pattern of rainfall, they're really being pushed against it. And we're seeing during some of the stormwater conditions, we're seeing a lot of the soil being washed away with the nutrients and the like, even though that we know they're actually trying their very best to do the best they can. In actual fact, a lot of the issues come down to us as gardeners and us as householders. There are, let's face it, many more of us. And, you know, when we're using things like slug pellets or fertilizers, it's very much in our interest to read what it says in the tin. There's always that temptation that, you know, if a couple of drops of fertilizer give you 6 roses, then if you double it, you're going to get 12. It doesn't work like that. If you use more, it's more likely to wash off. And those are things that farmers would never do. They couldn't afford to. Well, we as gardeners, because we're doing it at the smaller scale, we probably have that habit of overusing things when we definitely shouldn't. And the other thing, of course, is that when things go wrong, we tend to hear about them. So, you know, oil spill events, a car there going over the side into the estuary, those are the things we tend to hear about. But actually, what tends to be the bigger problem are the cumulative impacts of the drips of oil. You know, if your car and your engine drops in oil and everybody has a car, the number of drops add up. And that's the problem that we really have. It's not the big events that we hear about in the news. It's the frequency of the smaller events that are very often causing the bigger problems within our landscape, within our estuaries. It's hardly rocket science then that if we turn this on its head, if we all make small changes, we make small changes to our style of lives, we take greater care, that will also have a positive cumulative impact on the landscape and the estuaries around us. Things like litter, things like the litter that some of us mindlessly throw down without a second thought. You know, as an example here, the butt of a cigarette butt is actually made of plastic. It's not made of paper at all. So it's not going to rot away, and it's full of all the chemicals that it's filtered out from the cigarette. Garden waste, hedge cuttings, you know, in days gone by, we would have just thrown them into the nearest stream or river. But actually, our estuaries are already very high nutrient ecosystems already, and these things can just add too much. They can break the camel's back and start to cause us problems that we'll see in a moment. Excuse me a moment. And a heated mind is sort of sink disposal units. Yes, our wastewater treatment systems can break organic material down, but at the end of the day, those nutrients are going to flow down into our rivers, into our estuaries, and fertilize some of the problems that we have. So far better that our food waste is able to put into brown bins if you have one, where it can be heat treated and the nutrients can be reused back on the land again. Because of course, like we just said, at the end of the day, all those nutrients flow down to the sea. Road drains, our own drains, all flowing down. And the problem is that with the excessive nutrients reaching our estuaries, many of our estuaries suffer these green algal mats, the mats of seaweeds over the mudflats, and that ecology of over the surface of the mud that I described at the beginning breaks down. The anoxic layer comes right to the surface. You don't get the snails and things feeding at the surface, and the birds don't feed on them. You just get these great masses of green mat on the surface, and they just inhibit the normal ecology in the mudflats. And in certain places, we have another problem. Here in the Kingsbridge estuary, you can see that the line of red there in the water, that's caused by an organism called a dinoflagellate, and I've actually got a fluffy example of one here. Sorry. They are, we believe that the green algae are exacerbated by high levels of nitrates in the water, and there's a chance that the dinoflagellates are exacerbated by phosphates in the water. But in Kingsbridge, they're probably also made worse by the lack of flushing, because there is no river that is there to flush the water out. And sorry, go back a second. The dinoflagellates are able to synthesize some really quite nasty toxins. And if shellfish feed on these dinoflagellates, and then we eat those shellfish, we can get really quite seriously ill. So if we can all do our best to cut down the excess nutrients that get down into the water, we have to see a reduction in these blooms of these problem species. So, you know, it's what I'd love everybody to do is use their eyes and ears on what's going on around our estuaries. But part of it is understanding what is going on. This looks like quite a horrible kind of scum on the surface of the estuary here, but actually it's really quite natural. What's happened is that as the tide is coming in, it picks up a certain amount of the diatoms from the surface of the mud, and you get this diaceous scum that forms on the surface of the water. And actually, if you watch this happening, very often you'll have grey mullet fish that come and they feed on the scum from the surface. And if you've ever eaten grey mullet that's been caught in an estuary, they feed on mud, pretty much on mud, and they taste like mud as well. So that's the reason why. But keeping your eyes and ears open, this may look slightly similar, but look at the opaqueness of the water, but also what's in the water. Look for toilet debris, and if you see the likes of toilet debris, that's the time to ring the Environment Agency and report it in. So for all of these things, the Environment Agency are hoping for us to report the problem. Don't always expect a blue light if you report it in. Sometimes just feeding them information, they can build up a picture. And if, you know, something's always happening on a Friday, then they know they can start looking for things. They can look before they can tackle it. But particularly during COVID, they're not coming out unless they really need to. But I would really encourage everybody to put that number in their phones and keep their eyes and ears open, and to report things when they're going wrong. So things what we've done over time, you know, it wasn't so long ago that when people were scraping the necessary anti-foul from the bottom of boats, it was washed back down into the estuary. And, you know, the anti-foul is necessarily quite toxic to marine life because it's there to try and stop the build-up of fouling organisms on the bottom of the boat, slowing it down and needing to burn more diesel or whatever to power it through the water. So, you know, working with people, we have asked people to sweep up after themselves. And originally it used to go into a special bin, whereas now these days, boats are now cleaned and scraped over these specialist sumps so that it captures a lot more of the debris and halts it from going back into the estuary. It's actually very good for the management of the estuary too, because when it comes to dredging of the mud, if it's full of the anti-foul contaminants, it means that the mud has to be extracted and go to a specialist landfill site. Whereas if it's clean, it can be taken out to sea. And we have the support of the Royal Yachting Association and Green Blue, and we're all working together on that. Disturbance. You know, we really enjoy a lot of whales and dolphins and animals around our shores, things like the basking shark. And quite a number of these are actually protected by law against disturbance or reckless disturbance. And particularly now with COVID, our waters are quieter. some of these animals are enjoying coming in further. We're seeing seals hauled out where we wouldn't normally see them. And when we're all released back into the great wilds, well, if we want to see wildlife, we need to be a bit more careful as we go out there. There's also likely to be more of us, and we have to be very careful of that. So what we do as a unit is trying to raise awareness of, how our estuaries work, the kind of things that the impacts that we're having, and what we can do to help them. One of the things that I think we're most proud of is the production of a short animation we called The Drip. And it's been done by this guy, Tim Britton of Forkbeard Fantasy. And I'd really encourage everybody to watch it. You can watch it on the YouTube channel, and it's called The Drip. Says a lot of what I'm just saying in just 5 minutes. So, other things we do, obviously we, as a unit, we are looking at planning applications, and I look at a lot of the estuary ones. And we are at the moment, we're producing a construction environmental management plan guide, so that what we're hoping of developers will do is when they're looking at the build, they can look at the impact that their build is likely to have on the estuary, and look at ways that those impacts can be mitigated. And these days, of course, what we're encouraging people to is to actually improve the environment through their build as well. Things like storage of materials on the foreshore, transport of materials over the foreshore, building of fires on the foreshore. These are all things that should be considered and planned into builds, and that's something that we're encouraging people to do through this construction environmental management plan guide. Considering what we do with the clean rainwater runoff in some of our catchments, particularly in older towns and the likes, a lot of the clean rainwater is then actually combined in the combined treatment water system, so that within some of the storm conditions that we get, the system can get overloaded, and they necessarily release some of the untreated sewage into the open as well. Whereas if we could redivert that clean water, there's no need for the system to be overloaded, and no need for these releases. Lighting too. We're all very aware that things like bats can be adversely affected by light, but if you've got a property down on the water's edge, we need to be thinking about the impact it has on fish and life within the mud too. A lot of life actually times its reproductive process through the lunar cycle. So if you've got a property on the edge and there's a lot of light spill, it can upset that. To some extent, we can put some of these things right, but although it might be quite good in the amount of life that it supports, it doesn't often look natural. So it's always better to try and avoid these things if we can. Now, the relatively new problem on the block, if you like, is biosecurity. And this is the problem that we're having of invasive non-native species, and nearly all of the species here that we have within our local estuaries, things like slipper limpets, got out of my head for a second. That's a colonial sea squirt that we can get growing underneath some of our pontoons. It can really smother over areas. The Pacific oyster, this is a photograph taken in the Yelm estuary, and the Pacific oysters here have gone so dense that the local community have lost the amenity of that part of the beach. And plants too, this is cordgrass. It was actually almost a man-made species. It was too natural cord grasses that were brought together and initially planted deliberately to try and protect shores from erosion. And I actually got into this game. One of my very first jobs was actually to spray this Spartina with a chemical called Diatoms, and that's me spraying it up in the Eden Estuary in Scotland in, I guess, 1985. So more recently, we've been looking at these Pacific oysters. We've been mapping them and managing them where we can. And I'm hoping that with continued volunteer support, we will be able to manage them in places where the populations allow us to. Obviously, when you get a population like this, the horse is probably well and truly bolted. And unless we come up with some new silver bullet, you know, it's going to be some time before we can effectively do something about those. But it's very much in all our interests to prevent rather than cure this problem of biosecurity. And hopefully in the future, one thing that we will be able to do is reintroduce large numbers of native oysters. And they will also have the benefit of filtering the water. Now, native oysters live deeper down under the water, and it's highly likely that all the beds of our local estuaries used to be wall to wall with these native oysters, and the waters were that much cleaner because the oysters themselves were in such numbers that they were actually filtering the water clean. So in South Devon, we are incredibly lucky with the number of marine protected areas that we have. There are marine protected areas now in all 5 of our local estuaries and a lot of the local coast as well. And I truly believe this is something worthy of celebration and local pride. So the big answer of all of this is really to carry on doing all those little things that we already knew that we should. There is no one big magic answer that we can buy into. What we really need to be doing is carrying on being careful with our litter, careful with what we're putting down the toilet, down the sink, keeping, changing to electric cars, doing all those things that we knew we needed to do. And unfortunately, it's not just for today, but it's the day after and the day after that. We just keep having to do it. So I'd like to really leave you with this thought that the vast majority of marine conservation is really much more about prevention rather than cure. And it's really because it's such a difficult environment to work in that really to heal the great wounds that we do to the marine environment, we need to give it time. Maybe one day we'll have the technology, maybe able to do more, but at the moment, really, it's almost a form of rewilding. We need the marine environment to be able to heal itself. We just need to take away the issues that's causing the problem. So that's me finished. I will gladly take any questions. Thank you.
Okay, thanks, Nigel. If you just want to stop sharing your screen, I will